Hello and welcome to screencast number 7. We're going to pick up where we left off, and we were talking about the accident of the BP Petroleum's Deepwater Horizon oil spill in 2010, and we were considering that just drilling so deep poses several threats, and one of those threats is our ability to handle accidents that could happen as we move further and further offshore. So globally, there have been recent discoveries off the coast of Brazil, Angola, and Nigeria, and some other nations that suggest that there's a great deal of oil and gas that lie well offshore into these deeper areas. Companies are actually racing one another to get to these locations. We do have the ability to drill in deep water, and this has outpaced our capacity to deal with accidents there, as we saw with the Deepwater Horizon oil spill with BP. The fact that it took 86 days to plug the leak demonstrated that the challenge of addressing an emergency situation a mile or more beneath the surface of the sea is really a difficult and daunting task for us. Today, we're also looking on the Arctic. With global climate change melting the sea ice that covers the Arctic Ocean, this has opened up shipping lanes. It has opened up nations and companies that are scrambling to lay claim on the patches of the ocean floor that could hold fossil fuels and other resources that are available in these areas. The Arctic frigid temperatures and the ice flows and the winds and the waves and the brutal storms that happen present new harsh challenges and make accidents more likely. So we have to be able to handle those accidents. In 2008, responding to the rise of gasoline prices and the desire to lessen dependency on foreign oil, the U.S. Congress lifted a long-standing moratorium on offshore drilling along most of the nation's coastline. The Obama administration in 2010 followed through by designating vast areas open for drilling that had formerly been closed. And these areas included the Atlantic coast from Delaware, right off of our Delaware coastline, to south to central Florida, and a region of the eastern Gulf of Mexico that had not been opened before, and most of Alaska's North Slope was opened up. But then the Deepwater Horizon spill occurred, and the public reacted and forced the Obama administration to backtrack. So they canceled offshore drilling projects that it had approved, and they put a hold on further approvals until new safety measures could be devised. In 2011, after weighing the economic and environmental concerns, the administration issued a 5-year plan that opened up access to 75% of the technically recovered reserves to drilling, and these were offshore. They banned drilling offshore from states that did not want it, and drilling leases were provided and expanded off of Alaska and into the Gulf of Mexico, but areas along the east and west coasts were not open to drilling under this plan. There are risks of expansion into the Arctic water that need to be considered. In 2012 and 2013, these were highlighted when the Royal Dutch Shell's Kulik drilling rig ran aground while being towed south from Alaska during a storm. There was damage to the rig that happened, and examination by public officials and the media raised fresh questions as to whether Arctic Ocean drilling could be conducted safely. Let's go back and look at those new fossil fuel sources that we were talking about with oil sands, oil shale, and the methane hydrate. that we had mentioned earlier. The sources of conventional fossil fuels are declining and prices are rising, so we need to turn to increasingly newer alternatives. So the oil sands, oil shale, and methane hydrate are some of these alternatives. We've already mentioned that the oil sands are found in Alberta, and there are oil sands that are found in Venezuela as well, and these likely hold even more oil and are already significantly increasing the amount of oil available to our society. So oil from shale is not yet economical to extract, so that's one of the problems that we face. And the gas from methane hydrate is only now becoming technically feasible to extract. So we still have some barriers to get over with this. The world's known deposits of oil shale could contain as much as 3 trillion barrels of oil, and that's more than all the conventional crude oil in the world. But most of this will not easily be extracted. Possibly only 40% of the global oil shale reserves are here in the United States. And they're on federally owned land in Colorado, Wyoming, and Utah. So we're talking about in parks, places that have recreation and are there to preserve biodiversity. The EROIs, as we already mentioned, are very low. We're seeing a 1.1 to 1 ratio to possibly a 4 to 1 ratio. And if we think historically, these low prices for crude oil have kept investors away from shale oil. But every time crude oil prices rise, shale oil gains attraction and attention again. As far as methane hydrate, we are just figuring out how to extract this. Scientists believe that there's immense amounts of this substance on the earth, holding perhaps twice as much carbon as all the known deposits of oil and coal and natural gas combined. Japan has just recently showed that it could extract methane hydrate from the sea floor by sending down a pipe and lowering pressure within it so that the methane turned to gas and then rose to the surface. However, we don't know whether such extraction is safe and reliable for doing this. Destabilizing the methane hydrate deposit on the sea floor during extraction could actually lead to catastrophic release of the gas. This could cause massive landslides, tsunamis. If we were to release huge amounts of the methane, this is a very potent greenhouse gas, and it would escape into the atmosphere, worsening our global climate change from now. So there's many risks to being able to extract this. So again, technology has to be developed. When we think of our oils and our shale and the methane hydrate, even though they are abundant, they really don't provide any comfort to our energy challenges. Their net values are low, and their EROI ratios are low, and these fuels exert some severe environmental impacts that also need to be considered. So now let's turn to some of those economic impacts of our fossil fuel use. We'll look at some environmental, economic, and social and political problems that are faced, and we'll examine some potential solutions to these impacts. So fossil fuel emissions pollute the air and drive climate change. Let's just talk about these staggering facts. We burn fossil fuels and we alter the fluxes in the Earth's carbon cycle as we do that. Essentially, we take carbon that has been retired into a long-term reservoir and store it underground and release it into the air. This occurs as carbon from hydrocarbon molecules of fossil fuels unites with the oxygen from the atmosphere during combustion. and it produces carbon dioxide. Carbon dioxide is one of those greenhouse gases we've talked about and is released from fossil fuel combustion, and it warms our planet and it drives changes in the global climate. Because global climate change is beginning to have a diverse and severe and widespread ecological and socioeconomic impacts, carbon dioxide pollution is becoming recognized as the greatest environmental impact of fossil fuel use. Methane also is a potent greenhouse gas, and it also drives climate warming. Switching to new fossil fuel sources may only make emissions worse. When we look at the oil sands, they're estimated to generate anywhere from 14 to 20% more greenhouse gas emissions than conventional oil, and shale oil is even more polluting than that. Besides modifying our climate, fossil fuel emissions affect human health. Taking a look at this graphic, we can see the increase of the metric tons of carbon that are going up in a year. And look at that black line, that black total. It's just huge. A lot happening here. But we're going to see health problems. Combusting coal oil that is high in mercury emits the mercury, and that can bioaccumulate into organisms' tissues, poisoning animals as it moves up the food chain, and it presents health risk to humans that eat and rely on those animals. Gasoline combustion in automobile releases pollutants that irritate the nose, the throat, and the lungs, and hydrocarbons such as benzene and toluene cause cancer in laboratory animals and probably likely in humans as well. Gases such as hydrogen sulfide can evaporate from crude oil and irritate the eyes and the throat and cause asphyxiation. Crude oil also can contain trace amounts of poisons like arsenic. And workers that work at drilling operations and refineries and other jobs that entail frequent exposure to the oil or products develop serious health problems, including cancer. Combustion of the oil in our vehicles and the coal in our power plants releases sulfur dioxide and nitrogen oxides, which contribute to industrial and photochemical smog and add to acid deposition. We have fossil fuel pollution that is intensifying in our developing nations, and that the industrializing is rapidly putting more of these pollutants in place. Air pollution from fossil fuel combustion has been reduced in developed nations only because of laws that have been passed. The U.S. Clean Air Act is one of those laws that regulates the amount of emissions for public health. And the public policy has encouraged industry to develop and install technologies that reduce pollution. And that's where we get our catalytic converters from on our vehicles that filter and change what the exhaust releases. We need a wider adoption of such technologies in the developing world to reduce pollution. And that's where we need to go with this. All right, we're going to end this screencast here, and we'll see you on the other side when we talk about clean coal technologies and their aim to reduce pollution.